Welcome back dear student and Jai Swaminarayan. Today I will start your new chapter of chemistry, chapter number 4, Structure of Atom. Previous chapter, chapter number 3, we were discussed about atoms and the molecules. According to the Dalton's theory, atoms is a indivisible particle. So one question arising in your mind, is the atom is an indivisible particle? What is the structure of the atom? That all the things we will discuss in this chapter. So dear student, let us start with the fundamental point of the structure of the atoms, charged particles in the matter, what are the different types of the particle consist in the matter, and first model of the atom proposed by the J Thomson. So in this video we will discuss about the first model of the atom that is proposed that was proposed by the J Thomson scientist, right? So let us start with the atoms, structure of the atoms. We know that the atoms and molecules are the fundamental building blocks of the matter, right? We know that all the matters are made up of the atoms and the molecules, right? Matter consist of the atoms and the molecules. So the existence of the different kind of the matter is due to the different atoms constituting them, right? So different kind of the matter constitute the different atoms in that, right? Now the question arising in your mind, what makes the atom of the one element different from the atom of the another element? How the atoms of the one element is different from the atoms of the other element? Are atoms are really indivisible as proposed by the Dalton, or are there smaller constituents inside the atom? Are there smaller particles inside the atom? Right? So the question answer of this question we will find in this chapter in the structure of atom. So what is the structure of the atom? What are the different smaller particles inside the atoms? Right? That all the things we will discuss in this chapter. So first, let us start with the charged particle in the matter, right? What are the different types of the charged particle in the matter with the help of the one activity? Activity number 4.1. Comb a dry hair and take a comb near to the small piece of the paper, right? Does the comb then attract the small piece of the paper, right? So first comb your dry hair, right, and take a comb near to the small piece of the paper and observe that the does the comb attract the small piece of the paper? Yes, the comb attract the small piece of the paper. Why? Because when we comb a dry hair, the charge is transferred from the dry hair to the comb, and due to this charge, the electricity is produced in the comb, and due to this electricity, the comb attracts the small piece of the paper, right? Second point is that the rub of glass rod with the silk cloth and bring the rod near an inflated balloon. Observe what happens. So when we rub a glass rod with the silk cloth, right, the charge is transferred from the glass rod to the silk cloth, and silk cloth to the glass rod, right? A negative charge is transferred from the silk cloth to the glass rod. And when we bring a glass rod near to the balloon is attracted towards the glass rod. So due to this, with the help of this activity, we can understand that. So when we rub a two object with each other, when the comb dry hair, right, when we rub a glass rod with the silk cloth, the charge is transferred from the one matter to the another matter due to the friction, right? We can say that the charge is transferred from the one particle to the another particle, one object to the another object due to the friction, right? And the electricity is produced due to the friction, and this type of the electricity is known as the frictional electricity, right? So from this activity you can say that there are some charged particles in the matter. So positive charge particles are there, negative charge particles are there in the matter. So when we rub a glass rod with the silk cloth, the glass rod becomes the negatively charged, whereas the silk cloth becomes the positively charged. So from that activity, we can say that there are two types of the charge: positively charged particle and the negatively charged particle. And from that, we can say that the atom is a divisible and it consists of charged particle. So what are the mainly charged particles? Two types of the mainly charged particles are there. First one is the positively charged particle and second one is the negatively charged particle. So dear student, the question is asked in your examination like this: what are the charged particles, what are the different charged particles? So there are two types of the charged particle. First one is the positively charged particle and second one is the negatively charged particle, and the atom consists of this charged particle. So mainly the atom have a three types of the charged particle, or we can say that the atoms have mainly three types of the subatomic particle. They are electron, proton and neutron. One is the negatively charged particle, another is a positively charged particle, and neutron have a no charge, neutral charge. That means there is no charge on the neutron. So atom is made up of the three subatomic particles. First one is the electron, which electrons are the negatively charged. Second one is the proton. Protons are a positively charged particle. And third one is the neutrons. Neutrons have a no charge, right? Chargeless particle, neutron. So from that we can say that the atoms are made up of three subatomic particles: electrons, protons and neutrons. Electrons are negatively charged particles, protons are positively charged particles and the chargeless particle neutrons. Here dear student, the mass of the electron is 1 by 2000 of the mass of the hydrogen atom. By the experimentally, the scientists were found that the mass of the electron is a very less compared to the mass of the proton and neutron, right? The mass of the electron is 2000 part of the mass of the hydrogen atom, or we can say that the 2000 part of the mass of the proton. So the mass of the electron is a very small compared to the mass of the proton and the neutron. The mass of the proton is equal to the mass of the hydrogen atom, and it is taken as a one unit, right? So the mass of the proton is the equal to the mass of the hydrogen atom, and we are consider the mass of the proton is a one unit. The mass of the neutron is also equal to the mass of the hydrogen atom, and it is also taken as a one unit. So dear students, here the mass of the proton and the mass of the neutron is quite similar to each other, and it will taken as a one unit, but the electron is quite smaller than the mass of the electron. So mass of the electron is a less compared to the mass of the proton and the mass of the neutron, right? Understand dear student? So from this we can say that the atom is made up of the three subatomic particles: electron, proton and neutron. Now different scientists will try to establish the structure of the atom, and different scientists will propose the different type of the structure of the atom, model of the atom. From there, first scientist, they were he was first proposed the structure of the atom, that is the J Thomson. So before that, before the J Thomson's model of the atom, we will discuss some discovery of the charged particle in the matter. In the 19th century, J Thomson discovered the presence of the negatively charged particle. So by experimentally, J Thomson first were discovered the presence of the negatively charged particles in the atom, and it is called the electron in the atom, right? So J Thomson discovered the presence of the negatively charged particle called the electron in the atom. In the 1886, E. Goldstein discovered the new radiation in the gas discharge and called them a canal rays, right? So E. Goldstein discovers the new radiation in the gas discharge. A gas discharge tube there is there, and when we apply a potential difference to the gas discharge tube, the canal rays are produced. New type of the radiation is produced, and the E. Goldstein called them a canal rays. These rays were positively charged, right? This later leads to the discovery of the positively charged particles called the proton in the atom, right? So what are the canal rays? The radiation produced in the gas discharge is called the canal rays, and canal rays were a positively charged. Later these canal rays are discovered of the positively charged particles called the proton in the atom. In the 1932, the Chadwick discovered the presence of the particles having a no charge in the atom called the neutron, right? By the experimentally, Chadwick measured the mass of the atom theoretically and the mass of the atom practically, and this is somehow quite different. And from that, the Chadwick discovered that the presence of the particle having a no charge. There is no charge on the neutron. So neutrons are the chargeless particle, protons are the positively charged particle, and the electrons are the negatively charged particle discovered by the different scientists, right? And after that, the different scientists were made a several experiments to understand the structure of the atoms. And from that, for that, we are discuss here a first model, J Thomson's model of an atom. The J Thomson's proposed the first, the atomic model. So what is the J Thomson's model of an atom? So let us see the Thomson's model of the atom to understand the structure of the atom. So according to the Thomson, an atom is similar to a Christmas pudding. The pudding have a positively charged and the electron having a negatively charged work like a pump on the pudding, right? So according to the J. Thomson, so Thomson says that all the positive charge is distributed similarly like a Christmas pudding, and the seed in that pumps of in a pudding, that is the negatively charged electron like a pump. So J. Thomson's were first tried to discover the model of an atom, and according to the J. Thomson, the atom is similar to the Christmas pudding. Like this, all the positive charge are distributed like a pudding, and all the negative charge is distributed like a pumps in the pudding, right? We can also think of a watermelon. We can also think the water structure of the atom is like a watermelon. The positive charge in the atom is spread over all over like the red edible part of the watermelon, like this. All the red edible part of the watermelon is like a positive charge, while the electrons are stored in the positive charge sphere like the seeds in the watermelon. So the J. Thomson's model of the atom is a like a watermelon, or we can say that the plum pudding model. So this, that's why the J. Thomson's model of the atom is called the plum pudding model, right? So understand, dear student. So J. Thomson, according to the J. Thomson model, J. Thomson states that all the positive charge is distributed all over the sphere, and in the some specific location, all the negative charge electrons are distributed discretely in the model. But so, according to the J Thomson proposed that an atom consists of the positively charged sphere and the electrons are embedded in it, right? So, like this, all the positive charge distributed over the small sphere and negative charge is discretely distributed in the positive charge embedded in it. But another point, J Thomson's were proposed that the negative and positive charge are equal in magnitude. So the atoms as whole is a electrically neutral particle. So here the positive charge and the negative charge are equal in a magnitude. The positive charge, that means the proton, is uniformly distributed over the spread over the sphere, and the negative charge, the magnitude of the positive charge and the negative charge are equal. So we can say that the atom is electrically neutral, right? So J Thomson proposed that, but there are some limitation of this model. According to the static electricity, the continuous distribution of the charge is not possible. So the J Thomson, how the positive charge is uniformly spread over the sphere cannot explain by the J Thomson's model, right? But from the success of the J Thomson's model, the J Thomson first success of the J Thomson's model is that the atom consists the positive charge as well as the negative charge are the same amount, and atom is the electrically neutral particle. And from the experimentally, J Thomson derived that the size of his atom is about a 10 raised to minus 10 meter, right? So there are two successes of the J Thomson's model. First one is the atom is the electrically neutral particle. It consists of the positively charged particle as well as the negatively charged electron, right? And the amount of the positive charge and the negative charge are same. So the atom is electrically neutral, right? Second success of the J Thomson's model is that the size of the atom from the radiation occurs from the atom. The J Thomson were estimate the size of the atom is about a 10 raised to minus 10 meter, right? So these are the success of the J Thomson's model. But the J Thomson's model, atomic model, cannot describe the continuous distribution of the positive charge. According to the limitation of the J Thomson's, what are the limitations of the J Thomson's model? The uniform distribution of the charge is not possible, and the distribution of the negatively charged electron cannot explain by the J Thomson model. So dear student, understand the J Thomson's model of an atom. So now in the next video we will discuss the next model of the Rutherford's model of the atomic structure.